Right. Good morning, everybody. My name's Steve Morris, and I work for the Knowledge Transfer Network. I'd just like to ask you, all the people who are currently logged on, if you could just indicate that you can hear us okay by just typing into the box on the left that you can hear us. The sound is okay. Okay. So as I say, I work for the Knowledge Transfer Network. This webinar has been organised as a follow-up to a workshop that we ran on the 9th of September here in London to look at helping Innovate UK to scope a call on smart, hybrid and multiple materials. So just by way of introduction, I'm going to tell you what the KTN is very quickly. Then we're going to have a brief look at design and how it impacts on innovation. And then we're going to look at the outcomes of that workshop on the 9th of September, and we're going to invite comments. It's not working. Leave the slide on. Apologies for that. So the KTN, what is the KTN? It's the UK's Innovation Network. We bring together business and academia to help further innovation for the benefit of UK PLC. And as you can see, we're quite a large organisation, and we've got a wide range of industry groups, cross-sector groups. We try to work across all the sectors because that's one of the challenges in modern environments. And we've got 60,000 members, and we are funded by Innovate UK, who you'll hear about in due course. I'd now like to pass over to a colleague, Ed Hobson, who's going to tell you a little bit about design and how that impacts on innovation.
Okay. Good morning, everybody. Thank you very much, Steve. I think this is really important to introduce design into the smart material process. I'll go through the reasons why in the next sort of 10 minutes. So design is a cross-cutting theme within the KTN, so really seeing how design embeds into the innovation process. And this is really important in terms of bringing products to market, because in terms of what Innovate UK is interested in funding and looking at the potential for businesses to use design and really injecting design and incorporating it in early stage innovation in project lifecycle really improves the return on investment. And as businesses to sustainable growth, this is really important. So from our point of view, design is an absolute key driver for innovation. And why is this important and what's the proof? Well, it's through research and studies undertaken by the government, which proven that every £1 spent on design in terms of the innovation process provides, on average, a return on investment of a further £25. And this is a considerable input to work into the development process. And that's, if we're drawing on design, then who actually are the design community? Well, actually, the design community is around 200,000 people. And they can constitute and contribute to around 5.3% of the UK's GVA. So it's quite a considerable market that you can actually draw on in terms of designers to help with projects. This demonstrates the sort of different types of design engagements, and it's very much moving up that ladder from the no awareness of design at the bottom to moving to looking at design of the archetypal design of styling, how something looks, through the third box, looking at design really being part of the process of development, to the top of the scale, to really using design as part of the business strategy, which really starts to unlock some of the highest value in terms of return of investment. So we believe that using early stage innovation can provide economic growth, but also address environmental and social issues that might provide further business opportunities. So how does this relate to smart materials? Well, in effect, smart materials are new to existence. These are very much emergent technologies which have been developed somewhat in isolation, looking at the possibilities of how these materials can develop. We're very interested in looking at the market opportunities where these developments actually reside and meeting user needs in terms of where developments can actually grow particular users or markets and seeing where the opportunities are. So, in terms of smart materials and this whole core, what can design do for you? What can it do in terms of providing additional return on investment? Well, there are three things to go through. First of all, ensuring that smart materials actually meet the user's needs in the market and understanding what those are. Secondly, managing stakeholders' needs in the development process, trying to balance the stakeholders who are involved in getting the product from the lab through commercialization and to the end user. And thirdly, responding to market constraints, be they technical, be they environmental, be they financial. How do you actually use design to address those things that you have to navigate? So first of all, noting user needs in the market. This is very much about trying to understand what provides an attractive offer for the end user. And design can certainly help in terms of trying to identify the desirability, the usability, and the feasibility of what those materials and products might be. And then understanding it as early on in the process is essential in terms of providing as much flexibility for the design to actually contribute to the return of investment that's going to be ultimately delivered. So archetypally, you think about design as being just a look at a product, and the genius about Apple's innovation in terms of design is not about the look of these particular things and looking at the different generations of that development. Sure, they're very attractive, people want to have them, but the real key to their innovation and the use of design is actually creating a business ecosystem, which meant that the whole of the support of each of those products existed in an interlinked ecosystem where one product supported another and effectively created a new business model for those products and the delivery of those services, thereby capturing users within what is in effect a closed loop or a walled garden for that market. And Apple had to try pretty hard to keep their users. It's the brand, the value, the sort of the use and the functionality of those things which actually keep people want to be part of that ecosystem. So in terms of how design can contribute in terms of managing, it's a quite complex process getting from concept and through lab development, through different types of design in terms of prototyping, through the terms of finding finance, finding the right partners to work with, collaborations, and actually how do you commercialize the end. And using design in terms of those early stages is key, and where you have great flexibility to be able to chart that path and how do you understand the needs of each of those stakeholders. So it's very much about understanding how you manage those particular needs through the process. And clearly, each of the people involved in that stage have a different perspective, a different set of needs in terms of looking at lab development, actually doing work. In terms of manufacturing, it's actually, can we scale this up? Is it going to be, can we hit the right price points? In terms of actually how you realize that to a market, can you actually describe what the proposition is? Is it something that is going to be an effective and clear sell? And then ultimately, do people understand are aware of what the actual proposition, what the innovation is, what the new product is? So in each of these stages, it's about understanding how those different needs can be brought together. I think this diagram illustrates quite a neat sort of overlapping of needs. Effectively, design becomes a facilitated collaboration within quite a complex process. Processes of design thinking actually break down a lot of the complexity and try to simplify it into a sort of core issues and sort of rules which can be easily fed to those different stakeholders. And ultimately, it's about rethinking the business strategy. Any innovation is disruptive by its nature. And it's how do you work with that disruption, not only in terms of your own business model, but also in terms of your wider supply chains, and how do you innovate in terms of your business plan and your business strategy to deliver that. So thirdly, third area which can be contributed is responding to market constraints. Smart materials do not exist in isolation. They have to exist as part of a system. And that is in terms of the support that the market needs to bring, but also a set of constraints which the development has to work under. Now, these might be social, they might be financial, they might be regulatory, they might be environmental. But ultimately, it's how you can use design to increase the return of investment through using these processes and understanding how you can get your inputs to actually go further and for longer. So in terms of looking at perhaps one aspect of how effectively, how efficiently you can use materials in these processes, starting to consider how waste is minimalised, how resources are used most efficiently in that product, and then looking at perhaps a whole life cycle for that whole system. One of the things that Innovate UK and KTN have been supporting is the Great Recovery Project, which is one through the Society of the Arts. And this is very much about how do you understand the different business approaches, minimizing waste into making value effectively extend longer. So redesigning your supply chains, redesigning your materials, redesigning your manufacturing processes, and also redesigning your potential for recovering materials at the end of their life. The Horizon tool is something that KTN and Innovate UK are using, and I suggest it might be worth looking at the website horizon.innovateuk.org as really a way of understanding these drivers on sustainability in terms of what are the drivers that are going to be delivering a sustainable economy, and how can businesses really succeed in that context. It's a very useful tool. It sort of cuts across the different environmental, social, and sort of financial needs of making a sustainable business proposition. And certainly in terms of shaping some of the core towards competition, it would be useful to consider that. So these are just some of the benefits which Horizon offers in terms of actually helping to refine the core and really making a robust business case for the application of design within the core. So ultimately, how design contributes, and I think it's essentially can be important not to ask the question about is your proposition in terms of the core which is forthcoming on smart materials, is your proposition actually going to meet stakeholders and ultimately your users' needs? Secondly, is it commercially realisable at scale? And thirdly, is it actually workable within the market restrictions that we face at this point? And if you're having trouble sort of navigating those questions or actually understanding what the way forward is in terms of the complexity of these things, then I think being able to engage with the design community actually provides some easy routes to be able to address those specific questions. These are a number of organisations who are working within the field: the Design Council, British Industrial Design Association and Design Business Association, offering a range of resources to help them connect with particular communities. But perhaps closer to home, one thing that KTN is running is the Design Special Interest Group, which is a collaboration of up to 1,000 individuals in the community, bringing together entrepreneurs, designers, and really providing a hub for the start of that conversation around how design can contribute to the innovation process. There's a wealth of material, case studies, research, blog articles, and information on signposting about where to go next. So I very much encourage you to have a look at that in terms of this book.
Good morning. Thank you to Steve and Ed for the introductions, and thanks to Ed for the presentation on design. I'm Andy Sellers. I'm the lead technologist in the high value manufacturing team. Just want to check that everybody can hear me clearly. If there are any problems with that, type in a response and I'll make sure I keep the volume as loud as possible. Okay, so I've got a very brief introduction to Innovate UK, and beyond that, we have the outcomes from the workshop that we've ran at the IOM on the 9th of September. And during that second part, from the workshops, we have 6 slides for the different areas that we investigated, and we will be looking for your questions. So if you can be ready to type questions and comments for when those 6 slides come up, and we will have, essentially, we will have 6 Q&As. We'll have sort of 5 minutes per topic on those sort of 6 areas. So I'm going to start with a brief introduction to Innovate UK. We're the UK's innovation agency. Our remit is to accelerate economic growth by stimulating business-led innovation. This particular call comes through the high-value manufacturing team, and this slide shows the makeup of our investment for the year 2013-14, our commitment, and as you can see, high-value manufacturing is there in the middle. And essentially, high-value manufacturing is the link between subjects such as advanced materials, biosciences, electronic sensing and photonics, and end applications and challenge-led areas such as transport, healthcare, built environment, and energy. And we're essentially ensuring that the UK has the capability and the capacity to exploit this innovation that has been taking place at universities and to manufacture it here in the UK for the benefits of these challenge-led areas. How do we do that? Well, predominantly we do that through a mechanism known as collaborative research and development. This is a funding mechanism which brings together small and medium enterprises, universities, tier 1 companies. We put some funding in. It is matched funding with those other organisations, and the idea is to accelerate innovations coming out of universities and accelerate them towards market acceptance, towards commerciality. So this is essentially where we fit in the map from early stage innovation, early stage discovery at universities, and latter stage commercialization in business. And for those that are unfamiliar with it, it's a technology readiness level scale between 1 and 9. Typically, technology readiness levels 1 and 2 are funded by the research councils. This is fundamental research which is being done at universities. Business tends to become comfortable with exploiting new technology around about technology readiness levels 7, 8, and 9. And Innovate UK, this is an old slide that actually says Technology Strategy Board. Innovate UK fills the gap between university research and business. So we accelerate that growth. Typically covering technology readiness levels 3 to 7. Our investment criteria, clearly we're looking for good markets, growth, fast-growing markets, global markets. We also want to see that the UK has the capability and the capacity to exploit the idea. So that is at the research base, that's in small, medium enterprises, and also in larger tier 1 companies. It must satisfy one of the technology readiness levels within those bands which I showed earlier. And ultimately, this is about taxpayers' money going in to accelerate economic development. So does Innovate UK make a difference? We want evidence that our investment will make a difference, and that can drive the investment. And lastly, for the high-value manufacturing team, it needs to fit into one of the 22 national competencies. And this particular core that we have coming out next year fits into the competence smart, hybrid, and multiple materials. Okay, so here's the background. This is the funding which will be coming out early next year, in March of next year, in fact. Likely to be launched as collaborative R&D. And we will launch a £5 million investment as part of our high-value manufacturing strategy. And we will be putting together a funding document to explain exactly how to apply and exactly what topics that will cover. We're looking to fund innovation in the creation of smart products that combine smart, hybrid, and or multiple materials to create a smart system. A smart system is one that responds to its environment, creating a beneficial action, usually reversibly. So I've got a couple of examples here, but they are no means exhaustive. So, for example, a drug delivery system, which a capsule recognizes changes within the body and responds to changes in the active stimuli and releases its drug in that response. Or a crash helmet that changes in response to impact stimuli. Or equally, that could be a piece of armour for the military that responds in changes to impact stimuli. This particular call, there will be an emphasis on materials innovation and a focus on the manufacturing process. We're not looking for new material discovery. We're looking to capitalise on materials that we already know about and accelerate their scale-up production into end-user applications. Quite often, smart systems can be made up of electronic component software, and you can use a smart system that way. For this particular competition, that approach of combining electronic components and software is not in scope. Equally, biological systems are not in scope, but bio-inspired systems are in scope. Okay, so on the 9th of September, we ran a scoping workshop at IOM Cubed, and I have the outcomes from that workshop here. And essentially, we have 6 slides covering 6 different areas, and each slide has the outcomes, and we're looking really for your feedback and your questions and comments. So at the workshop, we divided the delegates into challenge-led teams. We covered the areas of built environment, defence and security, energy, healthcare, transport, and then we had another group of other, which was covered sports, leisure goods, consumer goods packaging. We asked those teams to kind of go through a 4-stage process to look at products that we're making at the moment or new products they might want to make, and look for opportunities or problems that they're solving. And then to think about the smart solution. So if you have a problem there, what is the smart solution? And the third section was, well, if there is a smart solution, why aren't we doing that now? So what are the challenges and the barriers that you need to overcome in order to implement that smart solution? This is a high-value manufacturing call, so we are particularly interested in challenges and barriers that relate to manufacturing. And the 4th stage was, if you've identified your opportunity, if you've identified your smart solution, if you've then identified the challenges and the barriers, then what is the action? What is the next step? And clearly, that we're interested to see that, because that enables us to assess if Innovate UK is going to make a difference. Okay, just to prove that we did actually hold a workshop, here are some of the outputs from that workshop. You might recognise some of the comments that you contributed to it. So as I say, I've now got 6 slides for the 6 different areas, and here is the first slide. So each of these slides are divided into the opportunity, the smart solution, the challenge, and the action. I'm not going to read out all the comments from these, but essentially, if you can be ready at your keyboard, and we're going to allow 5 minutes of Q&A per slide. So if you can type in your questions. If we don't have time to answer the questions today, we will record the questions, questions and or comments. Have we missed something? This is the built environment. So the main opportunities here were about controlling energy, in and out, throughout, for example, through roofs, walls and windows, controlling ventilation. There were some questions about retrofit versus new build. The smart solutions that came forward were photochromic glazing, energy harvesting, self-cleaning coatings, antimicrobial coatings. Some of the challenges were about the cost, the processing costs, bringing multiple functions together, high capex for processing. Do we feel that this is, have we captured everything here? Do you have additional comments? Do you have questions? Yes, the webinar is being recorded, and we will play that up afterwards. Yes, you can get a copy of the slides afterwards. So there's a question on building security. There was a comment about communication within buildings and providing with thermal storage materials. Okay, so there's a question here for buildings about thermal storage materials. Yeah, essentially, so the call is about manufacturing, it is about in the material space, and it is about building smart systems. So my understanding of thermal storage materials is that the thermoelectric materials would be in scope. The other thing I should say is after this webinar, if you want to make comments, contact either Steve Morris or myself after the webinar, feel free to do so. And possibly the best way of approaching, if you have additional comments you'd like to make, is to use this format of the 4 questions: the opportunities, smart solution, the challenges, and the actions, and then we can feed that into the competition process. There's a question here about building security. One of the comments that came out of the workshop was to enable communications within buildings, and the smart solution there might be interference blockers. So it might be materials that prevent hackers from disturbing communications within buildings. I don't know if that answers the question on building security. Okay, thank you. Are there any other questions or any other comments? Do people who were at the workshop recognise these topics? Do they think we've missed anything? Okay. This webinar is being recorded. It will be online afterwards, so you can go back and revisit it. And if ideas occur to you after the webinar, please feel free to contact us with either questions or comments or contributions. In terms of questions, just fire them to in terms of comments and contributions, as I say, probably we would advise you to try and stick to the format of opportunities, smart solutions, challenges and actions, 4 questions, and put down your contributions under those sort of 4 titles. Anything on demolition, smart disassembly. Yes, okay, so that topic has come up, and I might have recorded it under the wrong section, so I have recorded that under, I believe under defence and transport. So and so perhaps that's my error in not fitting it in within the correct group. Okay. If there are no further questions, on this, I guess, so in terms of the call document and in terms of the call, clearly we're looking for common challenges that might occur from one area to another. So that would make a very strong argument for that going into the call document. And the call document itself will not be sector specific. So it will be about our ability to manufacture these smart products using smart materials. Subsea and surface engineering. Have we covered subsea and surface engineering? Not specifically. I guess that the closest that would have come to perhaps is the energy section and the transport section. So feel free to make some contributions to this section or make some comments in the next section, and we'll cover that point. So we do have some definitions for solutions based on engineered biomaterials. So actual biological systems are out of scope, but engineered biomaterials are okay. They will be in scope. Okay, I'm going to move on to the next section. Was there a question on that?
Yeah.
Okay, smart has been discussed, but not hybrid and/or multiple. Where does this come from? Okay, we have some definitions for those which were presented in the presentation at the workshop, and I don't think I have them to hand, but I will attempt to answer that before the end of session. Brilliant, thank you. Essentially, we will come back to that, I think is the best thing. Okay, so we've moved on to next group was defence and security. And again, so we have this four kind of gate stage process that we led that team through. The opportunities, smart solutions, challenges and actions. I've underlined one or two terms here, essentially because just to ensure that my understanding of that terminology is correct. My understanding of MRO is maintenance, repair and overhaul. If I've understood that, if I've not understood that correctly, if somebody from the defence sector could kindly correct me on that. And I wasn't 100% certain what was meant by witness systems. So again, if somebody from the defence sector could. Great, thank you for correcting me on that. Perfect. That's three corrections there. Thank you. So I was uncertain. About witness systems and whether this was a specific program that might have been funded or whether this was a generic term within defence. If somebody within defence is able to correct me, that's great, either now or even offline, just so that we make sure we have our understandings of that. So again, really the questions here are, have we missed any opportunities? Have we missed any smart solutions? Have we missed anything? Is this what people recall from the workshop? The things that came out very strongly was pervasive environmental sensing and monitoring, techniques for energy absorption. We can understand why that would be important in a defence context. Directed energy, less than lethal weapons, cyber security, and some of the smart solutions to those we're using hybrid and multiple materials to control optical or electromagnetic properties. There's an interest in self-healing, particularly self-healing capsules, and self-repair. And we noted the comment, "Get me home." And my understanding of that is somebody in a critical scenario being under attack and sustaining some damage, but some degree of self-repair enables them to take shelter. One of the smart solutions might be smart fabrics and all responsive dielectrics. So some of the challenges there were fabrication techniques, access to materials. That one came out in a few of these actually. Specificity, if I can pronounce that, responding to a specific stimuli, not responding to multiple stimuli. And the actions from this group were a very clear interest in building the supply chain through consortia and using match funding in order to accelerate this technology through. So again, any questions? Any comments? Anything we've missed? And if we have missed them, feel free to update us offline. Anti-tamper should include anti-counterfeit. Okay, understood. I would say not. So going back, so materials definitions. Okay. So a smart functional material responds to stimuli in the environment, usually reversibly. A hybrid material are nano or microstructured materials, such as alloys, composites, or gels. And multiple materials are microfabricated, such as multi-layer, multifunctional films at the microscale. For this particular call, we are happy to include smart, hybrid, and/or multiple materials to create a smart product. So the smart product can combine these materials in order to create a smart system. And that smart system is responding to its environment, delivering a beneficial action, usually reversibly. Oh, thank you for the definition for witness systems. That's brilliant. Thank you. So I think we've spent 5 minutes on the defence and security. Does sensing include chem, bio, motion sensing equipment, health monitoring? Yes, we're happy with health monitoring. That we should have that in there. Yes, and if there are anything that we've missed, then we can answer. So if there are any of these questions that come in that we don't actually pick up, we can answer at a later date. If there are no further questions on this section, I will move on to the next section. Can you repeat that smart hybrid offer? Yes, okay. And actually, we had this in the presentation from the workshop and in the presentation slides that were made available. And probably the best thing is just we will refer people back to that presentation so you have a written definition for that. Okay, so the energy team generated a lot of outputs from this workshop. So the opportunities, smart solutions, challenges, and actions. The opportunities typically new materials that have low heat or eddy losses, electromagnetic materials. Opportunities in hybrid electric vehicle batteries. I've underlined one of the comments that came in was H2 embrittlement in energy storage, and I've underlined that from the point of view that I didn't fully understand what that meant. So if there is somebody from with an energy background, if they can provide us a definition for that, we'd really appreciate it. So some of the other opportunities. Eliminating corrosion in cooling pipes. There's a problem potentially with wind turbine blades and erosion of the leading edge of a wind turbine blade. There was discussion about capturing waste energy, improving the efficiency of energy exchanges. There's another comment down the bottom I have here, morphing bistable structures. And again, that was a comment that was made in the workshop. And I guess I just was looking for somebody to provide a bit more clarity and a bit more definition around why they put that in. Okay. Yeah, okay. Are oil and gas applications potentially? Okay, thank you. Hi, so we have a definition for H2 embrittlement. Understood, thank you. Are oil and gas applications included in this pool? Well, those sectors are included. What we're looking for is smart products using our definition of smart, responding to its environment. So if those products are going into the oil and gas sector, then more than happy for that. Great, another definition for hydrogen ingress there, thank you. Oh, okay, and there's an even somebody, and I should have done that to begin with. Thank you. Okay, so some of the smart solutions here were single magnetic composites, ferro piezo, flexible matrices, phase change materials, and the challenges that came out from this team were things like dispersion and alignment of materials, manufacturing within a moisture-free environment, reproducibility and market acceptance, scalability, long-term stability and durability. That came out in a couple of the teams as well, actually. And the actions were field trials, case studies, and use match funding in order to get that status. So again, have we missed anything? Do you want to add something to that? I think there don't seem to be any further questions around that. So we will move on to the next topic. This is healthcare. A lot of opportunities in implants, devices, diagnostics. There's a very specific opportunity here for addressing clinical needs in muscle rupture. If somebody from the health sector would like to provide some more clarity on that, that would be appreciated. A beneficial bacterial delivery system, recognizing good bacteria and balancing that against infection. Some of the smart solutions were self-directing materials, bioresponsive membranes, slow-release antibacterial agents to avoid infections and complications. One of the topics that came out in smart solutions was structural modularization. And the comment that was made that was for fractures and tendons, and I've underlined that. Again, if somebody from the health background could provide some clarity and expansion on that. Securing the medicine supply chain is important for this. So just thank you for that comment. The challenges are about scalability, some about modelling, perhaps animal modelling and clinical trials. There's a lot about clinical trials for this particular group. The actions were about identifying consortium members. Yes, so there's been a question here about antimicrobial surfaces, and I think we will give that some thought. And I think depending on how that responds within the system, it's at the system level that we're interested in, and how it's dealing with that. Then we'd be happy with that. So some of the other topics here, these came out quite a lot, was about unknown about the materials. So clearly our call will be about bringing consortia together and about accelerating the transfer of these new materials from the research base or from SMEs towards end applications. And hopefully the idea is that as a result of the project, that supply chain would have worked out its costs and its processing, and it will help every member of the supply chain to visualize their upstream and downstream costs so that they understand the scalability of that. Right. So thank you, Steve, for reminding me there. For people that are in the materials supply, we'd be extremely interested to hear and have if possible, have a database of people that are in this space of material supply. And we will then, in terms of structuring the call, we are likely to insist on having material supplier and an end user sort of tier one type in order to accelerate that pull through. So we know there's a lot of activity at the research space and in the SMEs in this area. So material suppliers that are looking to engage in this program, please contact Steve or myself. Make yourselves available. Tell us which materials you are involved with and which are the partners you're looking for. We will be running consortia building events and we can help accelerate that whole process. Okay, thank you. I'm kind of lab on a chip. So, okay, so no, lab on a chip. We are not. We're ruling out the scope of this particular competition. We have a question here about composite nanomaterials for imaging and therapy. Quite possibly. That question's just disappeared off the top of my screen. Bear with me a second. Yes. Again, if that's part of a wider system and it fits within our definition of a smart system, then I would say that would be in scope. Okay. What is the okay? So at the moment, so the next stage at the end of this presentation, I will be describing the next steps, and that will be our timetable for launching our documentation and actually launching the competition. And part of that is to structure the competition so that it gives the maximum benefit in terms of accelerating these materials and the manufacture of these materials in the UK. And I'm giving a lot of thought to number of members in the consortia and size of projects. And in fact, if you want to contact me either through this forum or offline about what you think would be a reasonable size project in terms of A, value, and B, timescale, then please feel free to do that. But I have quite a good clarity on that from the workshop. And my thinking at the moment is that we should insist on a minimum of somebody from the material supply at an early stage of the supply chain and somebody from a latter stage of the supply chain, an end user tier one. But we're giving a lot of thought to that, and that will be defined in the core documents when it comes out. Yes, yes. So our coatings in scope, and yes, providing it fits within our definition of a smart system. Yes, we absolutely. Okay, that quite possibly is a. Thank you for the comment. Quite possibly an error on my part in transcribing material that came from the risk material from the outcomes of the workshop into this stage. I guess it is self-material. Okay, thank you. And somebody has actually answered that question on my behalf, so thank you. But perhaps we will take that comment and perhaps we will cross-reference back into defence as well. I'm going to move on to the next topic now. So transport. So what were the opportunities here? Reducing drag, weight, downtime, impact detection and reporting, anti-vibration. The smart solutions were things like thermochromic paints, solar power fabric, self-healing materials, stiffness changing materials for carbonate, magnetoreological elastomers. The challenges here were the cost reduction. There was a comment made that the auto industry is extremely cost sensitive and they need to know their costs up front before them into the next model. There's also a roadmap quite often in the auto industry whereby new products have to be essentially on the roadmap now for introduction into a car, maybe sort of 6 years down the track. There was some comments about manufacturability, longevity of materials, comments about 30 years for aero industry and 70 years for built environments. I don't know if somebody wants to comment on those figures. And a general action here was that perhaps some sectors might be more willing to adopt these materials early on because cost was less of an issue, and that there might be the ability to transfer technology from one sector to another. For example, from aero to auto. So again, have we missed anything? Do we have any questions? Do we want to contribute something to this, these outcomes? Yes. So absolutely. Well, thank you for the question on disassembly and end of life. So I guess there are two things to that. And one is, if it's part of the smart system, it certainly is. But the other part of this is that our competitions have one of the questions is about kind of non-economic benefits, and it's about end-of-life outcomes. And we want to encourage the circular manufacturing economy. So I use the example of the mobile phone. We mine indium from China. We make indium tin oxide for our touchscreens on the phone. You use your phone for 18 months, and then you throw it in a landfill site. Indium is a pretty toxic material at best times. So there's a question here about how do we recover those materials at end of life and reuse them, or use non-toxic materials. So there will be an aspect of this competition which deals with end-of-life outcomes, reusing materials. Could be disassembly. It could just be a mechanism for reuse of materials, or a mechanism to use non-toxic materials. No. Yeah. Yeah. So we have a question here on high-speed rail safety and reliability. So we have the definition of a smart system, and I think we need to, when the core document comes out, we will give that a bit more definition. We have the definition of a smart system, providing your application fits within the definition of a smart system. That's fine, and you'll be asked to describe the innovation and the challenges that you're addressing in the materials processing. But in terms of an application in high-speed rail safety and reliability, have no problem with that as long as it's a smart system. And the same also applies to passenger and vehicle safety. There's opportunity for managing obsolescence. Yeah, okay. So I guess if your smart system was addressing an existing obsolescence, if there was an obsolescence which is occurring and you have a smart material a smart product, smart system that could go in there as a drop-in replacement for obsolescence, that would certainly, from a business perspective, you could identify the markets, you could identify what section of the market you could grab pretty quickly, and make a very strong economic case. Opportunities for joining of dissimilar materials. So it's fundamentally about making smart products that come under the definition of a smart system. If that involves the joining of dissimilar materials, fine, but it's not a fundamental aspect of the competition. Are there additional opportunities in autonomous vehicles? None that I can think of that wouldn't apply to other forms of transport. We've got stiffness changing materials for carbonate. I mean, is that going to be more applicable in an autonomous vehicle than a normal vehicle? I wouldn't have thought so. But okay, so I'm going to move on. Okay, so there's something about increased noise. Yes, so that could be an opportunity. So again, if you have a smart system that responds to vibrational noise and adapts in order to minimize that, then we'd be keen to hear about that. Okay, I'm going to move on because I'm kind of conscious of time. And so this is the other category. Again, opportunities, smart solutions, challenges, actions. And there were quite a few within this category. I've kind of mocked up quite a few comments that didn't fit naturally into the other categories, and just some general comments as well that I fed in here, just to ensure that they were recorded as part of the workshop. So two of the main opportunities that came out of this group, one of them was some discussion around sports shoes that adapt to running style, either enhancing performance or reducing injury. There was an emphasis on sensing, and there was also some discussion about smart materials that balance bacteria with cleanliness. In other words, perhaps we've gone from a situation where we had minimal bacterial control in our lives to a situation where we have extremely over bacterial control, and maybe we're being too cleanly, and maybe there's some balance there. So the smart solutions, some discussion about smart membranes and biostability. Again, have we captured what the comments are? Is there any other comments, any other questions around this area? Again, one of the challenges here, and this came out of a few of them, is, or two here actually. One of them was about designing at earlier stage of manufacture. In other words, kind of retrofitting a smart system to a car or a building is not the best way of doing this. The best way of doing this is to try and get buy-in at the early stage for cost effectiveness, and hopefully this competition will encourage that. And the other challenge here was a general one which has come out through a lot of these areas was general comments was we need material to play with. So again, the competition will encourage the adoption of smart materials and their use and their upscaling, and that will enable all the players in the supply chain to get a feel for their costs and their yield and how they feed that through and their lead times, etc. Have we missed anything here? Are there any questions? So there's a question here about manufacturing, focus on site materials. So the competition will be about manufacturing, yes. So it's a high-value manufacturing competition. So we'll be looking for, and there'll be further details in the core document. So it will be business-led applications. We are looking for high-growth potential business applications, a good market, identifying the market, identifying the growth potential, understanding where the innovation is in the manufacture and processing of these materials. We'll take on board all the comments that have been put into this workshop and into the webinar today, and they will then be addressed in the core document. So it will really be about, it's not about discovering new materials, it's about how do we scale these up, manufacture them at cost, get yield up, and actually develop smart products on the back of them and give the UK a competitive advantage in doing that. So, okay. Yeah. Okay. So, thank you for those comments. We will certainly take them into account. As we are at the end of the hour, I'm going to go to the final slide. Okay, so what happens next? So we had a scoping workshop on the 9th of September. Today we've had the webinar to disseminate those results. A competition brief will be published around the end of the year, and the actual competition will open in March of next year. So we will be promoting the competition and building consortia. We have, if you have any further comments, we will post all the comments and questions at the end. Okay. Okay, so these will all be put up on Connect as well. If you have any, so that's the time frame for what happens next. And we will put a group on Connect dealing with smart materials for this particular call. And then that will facilitate discussions. If people have further questions or comments, they can make that on the group. Perhaps they can also explain their area of interest or their capability, and that will be a signpost to other people looking for that. If you have specific questions, feel free to email Steve Morris or myself. Here are my contact details. And we will certainly look forward to your comments and contributions. I think, are there any other critical questions before we wrap up the session? That's okay. That's a good question. We're giving that a lot of consideration in terms of project size, and clearly the bigger the project size, the fewer the projects. I'm also giving quite a lot of thought in terms of how we can make projects which are cross-sectoral. So perhaps apply the same technique that enables a health outcome as well as a transport outcome and as well as a built environment outcome. And in which case, the money gets effectively multiplied by multiple, by addressing multiple sectors. We're giving that a lot of thought at the moment, but I take your point. And thank you for Fiona's comment there. Okay, brilliant. Thank you everybody for attending. Information will be on Connect. We'll set up a smart group on Connect. I will send you out links to that. Thank you very much for your time.